welcome back. Now you may remember me from the last videos. It is your magnificent math teacher, Mr. Byrd. Now last time you were seeing my image all over these videos, but I decided to try something a bit different today. So hopefully it kind of grasps your attention and just makes it a different experience for you. Last time we went over the first and second 6 weeks, everything that you learned. But now we're going to delve a bit into the third 6 weeks, which just recently passed. Let's begin with your vocabulary. You had words such as additive relationships, multiplicative relationships, base, exponent, powers, perfect square, equivalent expressions, prime number, composite number, and prime factorization. But that's not all. You also had factor tree, numerical expression, and order of operations. And that's just the first half of the 6 weeks. Speaking of which, you started with multiple representations. That's when you have different ways of showing a problem. For example, if we're talking about a runner running a marathon 8 miles an hour, for several hours, you could put it in word form or as an equation, such as D equals 8 times T. In this case, T is time, D is distance. Other ways to represent data would be, for example, with a table. You can also use a graph. Now keep in mind, these are just a few samples of the different ways to represent data. It's endless, really. As far as additive relationships, we're talking about relationships of data where if you have a table, something happens to your input to get your output. For example, in this case, we'll be adding. In example 1, you're adding 4 to all of those inputs to get those outputs. If you look at example 2, that doesn't work. You're not adding a consistent number each time. You're actually multiplying. And that leads to the next set of, the next relationship, which would be multiplicative relationships. But I'll get to that in a few seconds. Just remember, additive, you're adding to your input. And then there's multiplicative, like I said. In this one, you're multiplying your input with a number. And it has to be the same consistent number each time. You can't multiply each input by something different. For example, in number 1, we're multiplying each input by 2 to get your output. And again, it has to be consistent. Look at example 2. You're not multiplying your inputs by a consistent number. You're actually adding in this case. So make sure you pay very close attention to those details. And then we've got powers and exponents. With powers and exponents, what you're seeing here is you have some data that's expanded, like 6 times 6 times 6 times 6, and you want to shorten it just to be concise, to be efficient as possible in mathematics. And in this case, we're shortening it to 6 to the 4th power. In the second example, what we're trying to show you there is that when you have numbers like 4 times 4 times 4, we're going to use that number as our base. The amount of times that it appears would be your exponent. So how many times does that 4 come out? Comes out 3 times. So your answer would be 4 to the 3rd power. Another thing that you need to pay very close attention to is if you're given the information in exponential form, like example 3, what you want to do there is expand it. So 5 to the 2nd would not mean 5 times 2. It means you have 2 5s, 5 times 5. And the solution there would be 25. You can even do the same with decimals, like 1.5 to the 3rd power would mean 1.5 3 times. And then we've got prime factorization. What you have to pay attention to there is that you're getting a number and breaking it down. And there's several possibilities. For example, 120. One possible way out of several would be 6 times 20. If you notice, those are composite numbers. You can break them down a bit more. Just make sure you don't break them down too much. We don't want to have ones in there, because then it'll never end, really. You can keep breaking it down as like 2 times 1, 2 times 1, 2 times 1. It'll never end. So once you've broken it down to its prime factors, you're done. Just make sure if you have something repeating, give it to me in exponential form. We don't want to see 2 times 2 times 2 times 2. It'll look a lot nicer as 2 to the 3rd power. Now, as far as order of operations, one thing you have to pay attention to there is there's several strategies to help you remember it. One of the classic methods is the term Pemdas, the acronym Pemdas, or the more modern one is Gemdas, but they pretty much mean the same thing. The first one represents grouping symbols, commonly parentheses, followed by exponents. And then you would multiply and divide after that, and then add and subtract. And make sure when you do those steps, the last four, multiplying and dividing, adding and subtracting, that you go left to right. It's crucial that you always consistently follow order of operations. That way you can do math, no matter where you do math in the world, you will always get the same solution. That's why order of operations is so crucial to understand. And this pretty much sums up what you did the first half of the third 6 weeks. Coming up real soon, you're going to see several properties, one of which is the distributive property. You're going to see simplifying expressions, equations, writing equations, and representing solutions. Good luck.